Welcome to clickmyproject.com. We discuss about automated localization of sites in diabetes muscular edema using optical coherence tomographic images. In this paper, digital fundus imaging is used to diagnose various eye diseases like diabetes, retinopathy, diabetes, musculopathy, and age-related muscular diagnostication. Muscular is the main central part of retinal, which is responsible for shape, vision, and any changes in muscles causes several effects on vision. In this paper, we proposed a novel method for automated detection of muscular form digital fundus image perform pre-processing in muscular detection. It formulate a future vectors and use Gaussian mixer model with fuzzy classifier which concentrate on extracted features. Segmentation based factorial texture analysis algorithm is implemented to extract the texture feature from images. The feature optimization is done on the extracted feature to select the best feature out of its train the classifier. The classification is performed on the dataset and it's classified into two categories such as normal and abnormal. The query image is classified by the classifier to a particular class and the relevant images are retrieved from the database. Now let's demonstrate the data flow diagram. In this data flow diagram we consider for input image, Gaussian filter, segmentation based factor textual analysis and the classification and all the things performance for data set. Also the output is given into protein level. In the input images we selected for several images based on biometrics. The input images in selected for any one images, the output is given into Gaussian filter. The Gaussian filter consider each pixel in the image in turn and looks and its nearby neighbors to decide where or not it's representative of its surroundings. The median value is calculated from the surrounding pixel. The Gaussian filter replaces the defect pixel with the mean value. The Gaussian filter output is given to segmentation based fractal texture analyzed. The output is given into segmentation based texture analyzed. In the segmentation based fractal texture analysis, a new and efficient texture based extractions method is segmentation based fractal texture analysis. The extraction algorithm consists in decomposing the input image into a set of binary images from which the fractal dimensions of the resulting regions are computed in order to describe the segment texture patterns. SFT extraction algorithm asymptotic complexity is ONJTJ, where N is the number of pixels the grayscale images and JTJ is the number of different thresholds resulting from the multi-level OTS algorithm. The segmentation based factor texture analysis output is given into classification. In this classification we consider for testing and training images. The training is calculated for whole the data set, output is given into training set and the testing is considered for input images. The classification is performed for Gaussian mixer model is a parametric probability. Density functions is represented a weighted sum of Gaussian component densities. GMMs are commonly used as a parametric model of the probability distribution of the continuous measurement of feature in a biometric system, such as vocal trace related spectral features in a speak recognition systems. GMM parameters are estimated from training data using the iterative extraction maximization algorithm or maximum protein estimation for the well-trained protein models. The output is given into protein level technique. The protein level technique is extracted from the tissues with the touch extractor cellular. Matrix is often achieved in a laboratory setting by a impact pulverization liquid intelligence. Samples are forged and liquid nitrogens and subsequently subject to impact or mechanical grinding. As water in the sample becomes very brittle at this temperature, the samples are often reduced to a collection of fine fragments which can then be disclosed for protein extraction. Stainless steel devices known that disease pyrolysis are sometimes used for this purpose. Now let's we demonstrate the output. First we selected for main page and run the file. It is for guide designing for automated localization of size in diabetes muscular edema using optical coordinate tomographic image. First we selected for input image in dataset folder. It is of biometrics based funds image. It has for 20 image. I selected for 8th image. The input image output is given into grayscale. It is converted for input RGB to grayscale conversion. The output is given into Gaussian filter. The Gaussian filter, it is for noise reduction technique. It is removing the noise. The output of the Gaussian filter is shown in the output. The Gaussian filter output is given into binarization technique. The binarization technique, it is extracted the particular feature of extracted points will be output. It is represented for zeros and ones. The binarization output is given into testing features. The testing feature output will be shown. It will be extracted for 24 features will be extracted. The output is given into GMM classification. It is comparing for testing and training. It is performance for normal and abnormal condition will be checked. The output is the abnormal condition and the protein level is 74.5. Now we are analyzing for that output. It is finding the accuracy and sensitivity and specificity. Finally, we are analyzing the accuracy and specificity and sensitivity, comparing the both an existing and proposed method. Thank you.